Yeah, I would like to know a bit more about Cabri in physics. Like you can put physics parameters like weather, temperature, time. You can do graphics, all that with Cabri. Can you talk about that a bit?
I have to say that the current Cabri is not specifically oriented to deal with parameters, explicit parameters from physics like temperature or things like that. Yeah. But if you think about those parameters simply as values that vary from one value to another value or in interval or things like that, you can model, you can build models of physics phenomena.
Okay.
And what people using Cabri in physics, they simply build a model. Using geometric tools, they build the model. Then they can make the model directly working on the screen. With Cabri, you can build a model and make the model working. For instance, if I take a simple example, the simple modelization of the light rays in a lens. You can easily, because in that case it's very easily construct the direction of the rays after they pass through the lens using the standard geometrical optical rules, and then you can move the object and see how the image is moving, or you can change how do you say this, the foci of the lens and see what's happening, changing the lens from a convergent lens to a divergent lens, and look at for instance, to rediscover the so-called Gaussian position where the object is equal in size with its image, simply by dragging and making the model working. So this is one way. Another situation is could be also where you perform things that you normally cannot perform other way because it would be too complex to make the computation. Suppose you make a capacitor of a capacitor is made, an electrical capacitor is made of two plates with electrical particles on the two plates.
Yes.
But in Cabri we will simply put 10 or a relatively small number of charges and geometrically computes the resulting vector of all the action of those particles on all those charges on one given particles, and then you will, by dragging the particle from outside the capacitor within the capacitor, rediscover that the capacitor phenomenon, that actually the field, the electrical field is constant inside of the capacitor and almost zero outside of the capacitor. Something that is very difficult to understand because you are told that it is so, and you have to believe this. If you build with Cabri the situation, really putting a given number of charges on two plates, compute within Cabri the vector, the direction and the size of the vector produced by each charges, add all those vectors together, you obtain the resulting field, and then you simply drag and discover or rediscover the capacitor phenomenon.
Okay.
Like that.
Okay. Talking about modeling, I was told that you gave a conference about modeling a rainbow.
Yeah.
In Cabri. Mm-hmm. Can you tell me something about that?
That's the same. Typically, the same kind of situation. So, the rainbow is. It took time for the humankind to understand what was the reason for a rainbow to appear in the sky. I think it's at the time of Descartes, or somehow at Descartes' time, that people finally understood that this was a question of refraction and reflection inside of water drops that are in the clouds. And But if you perform the computation or try to think about this phenomenon in a standard algebraic terms, it's really complex to understand, and it's quite a magic that finally you can show that the rainbow will that the phenomenon of the rainbow will exist. If you do this in Cabri, you will simply model a drop of rain by a small circle, and construct geometrically the refracted
the colors,
and you discover that there is a concentration of light rays in direction that comes simply in dragging. You see the origin of the phenomenon, and you understand deeply the reason you have this concentration of reds that are in one direction in red, in the next direction in yellow and green, etc.
Yes,
so
all the colors.
In the colors of the rainbow.
Okay.
The idea is really to let Cabri perform the computation for you. You simply construct the things as they are happening in the real world, and then let simply you do not have to compute analytically yourself, because the system, the geometry itself will provide you with a result.
Okay. Another question. Can you tell me about Cabri around the world? Is the same? The people feel the same about the software everywhere, or there are some difference?
I know there is. This is interesting, and this is so from a cultural perspective. I think it's interesting. There is a tendency to think that about math or science it's the same everywhere. Somehow it's probably true, but somehow it's also not so true. And I will simply take a very simple example. When we started the Cabri in France, the Cabri was strongly influenced by the way we think in France at geometry, in terms of geometry being made of figures that are essentially abstract figures, not having any measurement in it. We are not interested in our culture about geometry in France yet in thinking that we have a triangle that has a length of 3 and 4.5 and an angle of 62 degrees exactly. And when we wanted to, at the very beginning, in the end of the 90s, when we wanted Cabri to be used in Germany,
yes,
the teachers in Germany, they said, "Oh, this software is absolutely cannot be used at all, because we cannot measure things. Okay. We need really to have a possibility to have the exact value of the angles, the exact value of the side of the triangle, of the length of an altitude, and things like that." And if Cabri today has quite an emphasis of measurement, and I think it's important to have the possibility, especially because of physics, to have the possibility to measure things. This is clearly an influence of the way people think about geometry in Germany versus the way we think about geometry in our country, in France. It's interesting because both countries, Germany is in French and France, are so close.
Yes,
you would think that it will be the same, but no. Somewhere it's really different.
Okay, is that because of the culture, educational culture of each country that causes that? Or why do you think there are those differences between Germany and France?
I think it reflects a very long history where it's well known that in the French culture we have been more interested in building theories, somehow not really empirical, not really based on data, but just more a construction of the intellect. And simply to speak about Germany, in Germany it's clear that their culture has been more influenced by engineer, where the question of measurement plays a very important role. And when I'm saying this, I'm not favoring one approach versus one other approach. I simply consider that it's really interesting to see the richness that comes from different. But between France and Germany, I think the difference started in the Middle Age, so it's not a new thing.
Yeah. Okay. And in other country, have you find any other difference like this one?
Yes, for instance, also if I'm going to Japan, the way in Japan people think about geometry is really connected to something they call, I think, shomei, and shomei is a kind of demonstration where, again, things based on the consideration of measurements plays a very important role. If we go to a classroom in Japan where people use Cabri, you will see their drawing are very covered by measurement everywhere. Okay. And if you do the same experiment in other countries, in the Americas or in Italy, you will be much less measurement.
Measurement.
So, they are using actually measurement in Japan a different way that they are using it in Germany, but it's clear that the different countries has a very different way of thinking about geometry proving, geometry exploring, and also the place of geometry in the curriculum. For instance, it's clear that in the Anglo-Saxon world, the geometry was more something supplementary, but not at the core of the curriculum. And in other countries like France, Germany, Italy, and also, for instance, if I'm not mistaken, in Mexico and in other countries like Mexico, the geometry is considered as a central part of the curriculum. What is interesting today in the US, for instance, is that for a very long time geometry was really not important viewed from a teacher perspective. So geometry was not a core subject in the US, but now it's changing, and they finally are going in the US more in a direction that you already had in other countries, including in this is the reason when we go in different countries in South America and Latin America, we have a competence level of teachers that's much more higher than in other countries where geometry was. So something interesting, but not something central to the education.
And why do you think that happened, that they didn't give much importance to geometry? Like you said, in US and Latin American countries, they gave more.
I don't know, but I think that they realize that to have people with a better education, or to have people more equipped to have how to say that, to analyze the data, to be more to exercise more criticism about what is said in the papers, in the journal. We need a higher level of education, and they finally realize that for people working as engineer, as a technician, they need more deeper understanding of science. And if you are thinking about what you need to quotation mark have a better understanding of what is globally in the science, you need a better mathematical education, and then geometry is as it has been in so many countries also finally considered as very central to the,
okay.
to the thinking, simply to the scientific thinking.
Yes. Okay, so tell me about your wife. How is the relation with her? Because you are in academically speaking. Yeah.
Okay, it's interesting, and I think one of the interesting situation we had in our group in Grenoble that the lab we had was a lab where we had mathematician, computer scientist, and people working in mathematical mathematical education. And so Colette has been the head of the department in Grenoble, which was part of the laboratory I was the director of. And this was a very interesting combination, because such a combination of computer science, mathematician plus and as an equal level math education is not so common. And this due to this combination, it has always been possible for us to have opportunities to be in contact with the teacher community, and not only to the teacher community from France, yes, but to the international community, having connection to what are the problems in different countries. And I told you how important it is to be aware that there are different culture about mathematics and mathematical understanding, and the value of this or this in the education and the math education, and a second aspect about what Colette was bringing to the project, I think, is her personal conviction that new technology, in the sense of putting the learner in the center of the process, was very important. And what we've tried to do with the Cabri was also to bring technology, but to bring technology for the user, not to ask the user to go to the technology, but really to bring the technology. And Colette is always advocating and favoring this direction. And for instance, it's clear to me that what's something that I consider myself as very important in the recent past, the fact that we have been able to bring the dynamic geometry, the Cabri geometry on the new on the 83, which is a very pocket size and easy to get handheld calculator. The fact that we have been able to do that, this has been with very strong support of Colette, because I thought other people were considering that this was not so important, because we could be interested in more fundamental quotation mark, fundamental subject, fundamental issues, but she had the view that what is important is to bring technology to everybody, and really to facilitate, to make easy for people to get to have access to that technology. And as long as we are concentrating only on computer technology, it's definitely not true that everybody has access to computer. Yes. This is not true in Mexico. This is not true in many countries. This is not true in France. This is not true in the US, because computers are somehow very complex and not easy to get piece of technology when compared to handheld devices, to pocket calculators, graphing calculators.
Okay. So one last question about Cabri 3D. Which are the primitive figures that the software will include?
Two things I'd like to say about Cabri 3D. One thing is that it would be possible to think that doing something in 3D, having already good expertise in 2D, is simply a matter of adding one coordinate to everything. Actually, it's entirely not correct. So going from a 2D environment to a real 3D environment is much more than adding one coordinate. I wanted to explain that for the Cabri, what is important to me is the way people interact with the object on the screen.
Yes.
And in 2D, it seems relatively obvious the way you can manage the user interaction with 2D geometrical objects. When you think about 3D object, it's not so obvious. I will take simply one basic example. You could think about 2D geometry as made of, as in Euclid, as points and lines. And to draw a line on the screen is easy, because you have something that is close to a line that goes from one part of the screen to the other edge of the screen, and this looks like a line, and you accept that this is a line. If you think about a plane and how to represent a plane on the screen, there is no way to represent a plane on the screen, because the plane is infinite, and the plane will occupy at once the whole screen. So you have to find a way to limit the size of the plane, and it's a common habit on textbooks to limit the plane to somehow to some kind of rectangle. But this is very arbitrary, and this works on picture on textbook, because the picture on the textbook is not a dynamic one. If you want at the same time keep the dynamic and limit the representation of the plane to something that has to be limited to be seen. If it's not limited, it covers the whole screen. You can't touch it.
Yes.
It's really a question that it was not entirely foreseen when we've started the project.
So the problem was that 3D was more abstract than 2D. It was.
It's not a question of abstraction. I think. Yes, somehow you're right, but I think it's essentially that the situation is essentially more complex.
Yes.
Essentially more complex. It's the complexity is not simply adding one coordinate. The complexity is everywhere. And I take another example to explain this. If you go to most of the textbooks in space geometry, what we call space geometry in some countries, so 3D geometry, you will see that most of the pictures that are represented there are no more than 10 different pictures that you can find in all books. They are essentially all the same, and you recognize them immediately. Especially if a teacher has the expertise to recognize the question is, when you start to move things around to change the direction of the planes, the figure, it's very difficult for the user to if the software is not good, if there is not enough good rendering of the construction, to let the user still perceive the same construction. If you go back to 2D geometry, you start with a triangle, and the user, the learner, the teacher, any user will drag one vertex. When you drag a vertex, the shape of the triangle is changing, but as a cognitive subject, you will perceive the triangle as still the same. Yes. It's your triangle. It's a triangle you have drawn, you have constructed on the screen, and even if you change its shape, you are really convinced it's still the same triangle. Quotation mark the same triangle. So it's not exactly the same, but mathematically it's still the same, and you are easily convinced of that. And this is your real profound feeling that it's the same. If you do this in 3D without enough thinking, without enough good design of the software, the figure will be a real mess after you have dragged some parts of the figures. And as the person in charge of this construction, you will even yourself be lost and not able to continue to perceive this figure as your construction. So you lose control. And to avoid that the user is losing control, to find the way in the rendering of the construction, the rendering means the way it looks like, the way the color are used, the way the thickness of the objects are used. If you are not looking at this very carefully, you end up with a software which is absolutely unusable, because as soon you use the software for a while, you are completely lost. This is the reason, by the way, there is until now essentially not serious software in 3D geometry in the sense of dynamic geometry. Most of the software that are currently existing, I'm not speaking about professional software like AutoCAD or things like that are more for the professional workplace, but for education there is essentially nothing still existing, because again, as it's difficult, it's inherently difficult, it's inherently complex to there is an incredible big amount of issues to be looked at, and problems to be regarded, and things to be fixed to obtain a good usable software. And we are not interested in simply producing a software that nobody will use. We are interested in producing a software that people will really like, use, and make it simple.
Okay. So yeah, those are all the questions. Thank you a lot for
thank you.
your time.
I beg your pardon for my passion about the way I'm trying to give some, to transmit some of the ideas behind the Cabri project. And but I think the core is really in the name of Cabri. Cabri meaning it's an environment where you can explore an exploratory sketchpad. An exploratory Cabri means cahier de brouillon, so a sketchpad, exploratory sketchpad.
Okay.
La traducción de Cabri, del francés.
De hecho, le iba a preguntar eso. Okay.
Did you answer that part about there being predefined
No.
objects in 3D?
Yeah. So
yes.
Very very shortly. That this would have been the easy part of the question. The same way 2D geometry starts with basic shapes, basic objects, primitives, like points, lines, line segments, circles, conic section, and then some basic construction, perpendicular bisector, etc. In 3D, the idea is to keep the same reference, and we have from the very beginning through tools. The main tools can give you access to points, lines, and then planes, subplanes, half planes, part of planes, or limited facets and polygons, and you will arrange them to make them as a construction, and you can build on them other primitives that are related geometrically related to the preceding one, like in 2D, but simply that there is more flexibility about parallel line to a plane, parallel line to another line, perpendicular bisector as a plane between 2 points, or perpendicular object from one line segment in a plane, so the regular 2D perpendicular bisector, things like that. So it's on this respect, is really an extension of the object we have in 2D geometry to Cabri 3D. will give access to the extension of the objects in 3D. So this is a place where we are simply extending the 2D. The rest of the problem for 3D is really about thinking about the good rendering, the how to represent the construction in a way on the screen that is unambiguous for the user. That the user is really convinced that he is working with his construction. He knows exactly when he looks at the figure, he continues to perceive what he was doing with this figure. And the second issue is about the interaction, how to allow the user to drag things, to change the relative position of objects among other objects. So what kind of interface, user interface you give to you build inside of the software. This is the part which is not obvious when compared to the regular 2D situation.
Okay. So yeah, thank you a lot.
Thank you.
I think that's all.
It is double, 6V. Three times W.
www.
.cabri.com. And on this side, there is one page where we have indicated some other links to other websites, including some good website. And for instance, the website Laboratorio de Triángulos from
the one they show
is of course reference. You can find again his address from our site.
Okay.
So and some of the sites are sites for the use of Cabri in physics.
Okay, yeah, I will check all that. Thanks.